Well, good morning and welcome back. I believe many of you were here yesterday listening to Mr. Giordano's speech, and he talked about smart grid overseas project and some demonstration project overseas. And today I think he will talk about that in more details. So I think we will have a very good learning experience from Mr. Giordano today. And Mr. Giordano is a managing director of Energistics, which is a energy consulting firm based in New York City. Yesterday, he also mentioned office, the building, and actually we visited his office last November. It was really a good experience, and that building is one of the must-to-see buildings in New York. So next time when you have a visit to New York, I think Mr. Giordano will do a tour for you. Okay, so now let's welcome Mr. Giordano.
I've been requested to use the microphone. That's okay. Okay. So first, good morning. Good to see a lot of you. I see some faces from yesterday. There will be a little bit of repetition from yesterday, but there will be more discussion of technology today. And in particular, I would like to have as much open discussion as possible. So of course, I'll lead the discussion, but I'd like very much to learn about your experience. The more that I know about what your experience and interests are, the more I can speak about the things that are really interesting to you. Does that make sense? Everyone okay? Okay, wonderful. So again, let me do a quick introduction. We're going to talk about the energy market. I'll explain a little bit more than I did yesterday. We're going to focus more today on different technologies that are related to both the smart grid, and then to green buildings, energy efficiency, electric vehicles, and anything else you want to ask. If you don't see something here that you want to know about, just raise your hand, and then I'll point to you, and we'll listen to what you have to ask. We'll look at just a few project examples as well, and then we'll have lots of time at the end for question and answer. Okay, so for those who were not here yesterday, I'd like to tell you a bit more about my background so you know what my experience is and why I'm here. So again, my name is Joshua Giordano. You can call me Josh. And as I've been told many times, my last name is very easy to remember. It's the same as the big clothing store in Asia. Unfortunately, I don't get any royalties or any revenue at all. So it's a bit of a scam for me, I think. I was born in New York City and was raised there. So a lot of what I will say comes from the perspective of someone from North America. However, at the same time, you see we have a representative office in Tokyo. I started my career at Mitsubishi Corporation, worked in both New York City, in their office there, and Tokyo. And I started as a trader of energy and metals products, which explains both why I have a connection into the Asian market and why I work in the energy industry. And we've done quite a lot of work in Europe as well. A lot of this is based on energy deregulation, which we'll talk about more in a moment. And to give you a background of my business background and my company, we work in 3 areas. So first is in energy specifically for energy companies, and that very regularly means utility companies. We focus on power generation, but that also means the energy supply that powers the generators. So just to start off some back and forth, please tell me one fuel source for power generation, please. What is a fuel source for power? Bananas? No. Maybe someone does that, I don't know. Coal, okay, thank you. Coal is one, natural gas is another, nuclear fuel, and these days more and more renewables as well. So we work in power generation, but we also work in the supply chain of fuel for power generation. That means natural gas production, that means LNG production, distribution, shipping. That means coal production and shipping, and again as well as renewable resources. So this is the energy supply side of our business. Then there's the technological part. That often means these days supply side, load. That means energy efficiency. That means software. That means programs that try to reduce energy consumption so that power plants don't have to be built, or so that the grid, power grid, is more stable and secure, especially in summer and in winter. So the technological part, and then last but not least is policy. So much of what happens in the energy industry is based on government policy. The environmental side, so say CO2 regulation, is completely a government mandate. It's not a natural market. The government makes a rule, and then we should follow. What it means is the government needs a lot of support, a lot of understanding of what they're going to decide. And so we work in both the US government and with the Japanese government to help them with basic understanding of energy security, environmental issues, and energy technology as well. So far, okay? How is my English? Is it okay? Yeah, I studied a long time. Ever since I was very small. I got good grades too. Actually, not such good grades. So I have worked with many companies that were trading with Enron. I never worked for them directly, but that is actually very close to some of the experience we had. We started in the US in late 1990s. Enron was very, very active in the trading of energy. And I know they came to Asia very early on. The Japanese were very nervous. Enron said, "We want to buy your power plants." And the Japanese government said, wait. So that will give you a very good idea. In the next couple of slides, we can have some discussion about this. This just gives you a basic idea. We've worked worldwide. I can say most of the world, we've not been in Africa at all. I haven't worked in Russia, but most of the rest of the world, we've had some dealings at one level or another. Either we've worked for clients in that country, or our clients in the US or Europe have asked us to do research in these areas. Okay, I won't go through all of this. It's a big, what I call, laundry list of different technologies, but when we talk about power generation, it's going to be new technologies. All of these things we can talk about. I'm comfortable in giving some opinion. Doesn't mean I'm expert in everything, but at least I can give you some direction for just about all of these things. I'll mention in this slide just 2 things at the bottom that I think are not so usual to talk about with energy, but if anyone here is interested in kind of cutting edge, really new technology, those things are maybe useful at looking at. So carbon fiber, everyone knows about this. So I think maybe, okay, let me explain a little bit about these topics. All of this list are basically standard things. The last two, first, one of our clients in Japan is the largest carbon fiber manufacturer in the world. So we sort of accidentally got a very good education in carbon fiber. We're energy people, not materials people. So, okay, carbon fiber, what is that? But over the years, we got to understand that first, carbon fiber is extremely strong material. It's, well, stronger than basically any metal. But most importantly, it is also much, much lighter than most metals, including aluminum. So the strength to weight ratio is quite high. And because of that, the material is used, it's still expensive, but it's used wherever strength and lightweight are important. So where would that be? Someone please give me an example of where you find carbon fiber. Tennis rackets, very good. Excellent. Do you play? Oh, great. If anyone needs a tennis partner, please see the gentleman. And bicycles, very good. Strength and lightweight. That was actually one of the earliest, very good. Airplanes, and really, well, we're going to have a lot to talk about. It'll be very interesting. Airplanes is the latest example. The latest Boeing 787 had some battery problems, but it's a separate issue. That's maybe, I don't know if it's half carbon fiber or a large percentage is made of carbon fiber. Now, I mention all of this again because weight is directly related to energy consumption. Yes? So any country that has a fuel requirement, fuel standard requirement for automobiles, the US just made a new law that requires a certain efficiency for automobiles, is going to push to start using more carbon fiber. The only way to get more gas mileage and more efficiency is to reduce the weight. So carbon fiber will become absolutely more and more important. Wherever you have something that requires energy and is moving, very important. And of course, tennis rackets are moving as well. You want something lightweight. Bicycles, you're going to see it more and more, I think. And it's something that people in the energy industry aren't really thinking about yet. So if you want to look into that, you might have a special niche or be able to talk about something that not a lot of other people know about. And graphene is even more advanced, something I know even less about. It's not a structural component, it's carbon, but it's single layer nanotechnology. And it's getting a huge amount of press lately because it has two very nice properties. One is as a conductor, conducts electricity. So I think maybe in Taiwan it's probably now a very big thing because the chip industry, I'm sure, is going to be very interested in this technology. But it also has a crossover. It's just as important in energy because it has also very good heat dissipation properties. And so for LED lighting, it can be used as a heat sink. Also for any electric engines where you want to draw heat away for generators and turbines. This will be a very, very interesting thing. And it's also very new. It's still basically in the laboratory. They're just starting to bring graphene into testing in the real world. The last part about that that's interesting is it's extremely cheap to make. It's just graphite. And so it looks like we have the beginnings of a really wonderful technology that almost anyone can start to work with. And I mention that just because it won't be in any other part of our discussion, so I want to mention it now. I highly recommend people look at it. And rare earth, This is very important also for the electronics industry. The energy industry needs this because a lot of the rare earth elements are found both in batteries as well as a lot of the high-end motors for electric vehicles. Some of my other clients in both the US and in Japan are very sensitive, and mainland China has most of the supply of this material. So there are a lot of companies looking at recycling this material, finding new sources, recycling, and basically how to sometimes eliminate the need for that material as well. So one other topic. Yes, please. Carbon capture and sequestration, yes. Not at all. Not at all. Sure. It's offshore has been discussed. It's even more expensive than onshore. Problem with onshore is that there aren't a lot of natural sites. There aren't. You need an underground cavern, empty space, to store the carbon. And onshore, there aren't necessarily a lot of good places or easy to find places to store the carbon. Okay, let's talk about energy markets. Forgive me again if we discussed this yesterday. I'm going to go into a little bit more detail today. I may not have explained enough about this yesterday, but I think this is, if anyone is interested in the wholesale energy markets, these are the critical concepts. Has anyone studied this before or had any experience? That will give me an idea of how much to explain. Done a little bit, right? I know you're doing modeling of the wholesale market. Okay, please help me explain to everyone. Yeah? No, it's okay. I'll ask you a little bit at a time. Don't want to put too much pressure. Okay. So when you talk about energy deregulation, this started in the 1990s in the US, Europe. Actually, Scandinavia was the first market to open up. Have you studied the NIPOL market? Yeah, NIPOL is very good. That's the market that opened in Norway. They were the first ones, I think, maybe 1992. And what we mean when we say deregulation was they separated the utility into power generation and transmission. They became separate companies. I think maybe the best example I usually use is the phone system. Everyone knows the phone system, right? When was it in Taiwan that the phone system opened up? Any guess? In the US, it was 1980s. 1980s, in the early 1980s, there was only one long-distance phone company, one local company, and calling anywhere outside of my city was extremely expensive. So we would basically dial the phone, hello, everything okay? Oh, okay, thanks, bye-bye. $10 just for that. It was extremely expensive. And then it deregulated. We had then many companies competing. When, again, does anyone in Taiwan? In 1990s. Okay, perfect. Perfect. So everyone has had this experience maybe around the world, I think, at this point. It's the same concept. The government said, okay, these wires are a natural monopoly. So we will pay a company to maintain the wire. So part of your bill, part of my bill, is to maintain all of the infrastructure and the billing. But anyone who wants to start a phone company basically can rent or borrow the wire, right? And then start a new cell phone company or anything that they basically would like to do. It's a little bit different in different places. Take that same exact concept, now put it into electric production and also the natural gas industry or pipelines. So now all of the wires are there. It's a natural monopoly. The utility company is now maintaining those lines. If there's a tree that falls, That company has to go out and fix the wires. They are responsible for the bill. And they're the ones that you talk to. But behind the utility can be 50 different companies that are producing the electricity. The utility is buying, in most cases, hopefully, the cheapest power for the rest of the community. In some cases, you can also go directly outside to another supplier yourself. And in the US, we have, say, green energy companies. They send us letters all the time. Please switch to us. We're very green and very nice. And we only cost this much more. So you can go outside and go to who you like. It's no different than buying a different cell phone provider. How many companies are in Taiwan providing cell phone service? 4. Okay, perfect. Much better than 1. Right? Okay. Creates competition, and it creates new technologies, and maybe some cost benefit. Not guaranteed, but usually that's the idea. Okay. Again, take that whole concept and try to start thinking about that for energy. It's exactly the same. Now, these charts up here, let's make another concept. Let's say that you live right in the center of Taipei. So many cell phone towers. And for the cell phone provider, it's very cheap to give you service because there's so many people in such a small area. Very easy to maintain all of the cell phones and the towers. But now you decide you're going to move to the top of a mountain. Right? What will happen to the cost of providing that cell phone? Will it go up or will it go down? It goes up a lot. Right? It's very expensive. You have to maybe put in some kind of special microwave tower up on that mountain just for one person. You're going to charge a lot of money. So that's, oh, guess I'm going to be high-tech and use a laser pointer. I'm old-fashioned. I don't like doing this. That's the mountain. The red one is the one guy paying a huge amount of money because he's not living in the central area. And the blue is a much cheaper area, lots of towers. Okay, now again, let's take this over to electric production. This is a guy on a mountain, basically, or an area where there are very few transmission lines coming in. So in this area, they have to start an old, very dirty power plant just for a small amount of people, just to give them their electricity in the middle of the daytime. If everyone lives in an area where there's lots of production in the middle of the city, it could be cheaper. Again, same concept for electricity. Noontime, in the middle of a very hot day, people in this area, this is probably a very dense area with very little transmission coming in, the price will go higher. And for electricity, the price will change hour by hour by hour. So this is a view of a nighttime. The price comes down. Same concept as a cell phone tower, just move it to a more real-time pricing curve. So higher in the afternoon when everyone is awake. One of my favorite examples of this, in the US, most of the price curves look like a bell curve, very relatively smooth curve. Highest is between 11 to 2 p.m., middle of the day when it's hottest, and of course goes down at night. So Japan, every country has a different curve, and Japan has it going up as usual, and then around 12:30, goes down. Everyone goes to lunch at exactly the same time. All the computers go off. It's amazing. What was that? Maybe, well, they are also very good at turning off the lights and everything, but it's just interesting that you can see on the electric consumption chart, everyone all at the same time. It's really amazing. You can tell a lot about a culture, I think, just from the electricity. See, energy is very important. That's better. Okay. Yeah, maybe someone can design a... Okay, let's see. All right, so the first point I think we made clearly, everyone hopefully understands. Provided open access for power grids, lots of new generators coming in, both for standard gas or coal power plants, but also now for wind and solar plants as well. Opportunity inspired thousands of new companies. And what we're going to talk about today is not so much the power plants. That's relatively old technology or simple, easy to understand technology. In general, we're going to talk about all of the new, really new technologies that have come in to support all of these new entrants into the market, as well as the residential side of the market. So for commercial buildings and for residential buildings at the same time. So new technologies, smart grid, environmental benefits from energy efficiency, and also better reliability of the power system. So far so good? Please stop me at any time. Okay, excellent. And don't worry, no test at the end. Okay, this is just to show that deregulation occurs. Everything I'm talking about is not consistent in every region. So even in the United States, it's not across every state. The lighter areas still look like what you have in Taiwan, which is one power company that controls everything. So in the places with the fewest people and the cheapest power, they stayed the way they were. They said, okay, we're happy. We don't need any new technology. Don't change anything. The regions in, say, Texas, California, and all of the Northeast, the highest population areas, all deregulated. So population-wise, the U.S. is mostly open and deregulated. State-wise, it's about maybe half and half. Okay, this is simply to show that in every study that's been done, energy consumption is predicted to only rise. And something we didn't talk about yesterday is if you look at the consumption statistics in the red area, almost all of the growth is non-OECD, which I think everyone sort of can understand intuitively, just thinking about it. Okay, BRICS countries, including Taiwan, are growing much more rapidly. Maybe some of the reasons we could speculate. I'm not an economist, but manufacturing has gone offshore for many of the U.S. and European countries. But another part of this as well is that if we look at deregulation, it creates a lot of incentive to create new efficiency. And so energy consumption per GDP in the U.S. has stayed very flat. We've still used more energy, but it's matched perfectly with GDP. And I think that's something to consider. It's becoming not only are non-OECD countries, of course, growing, but that flatness doesn't mean that OECD is not growing too. They're just becoming more and more efficient. I would say especially Europe. And then on the right side, probably could talk a whole day just about all of this, but I'll mention for now a couple of things. First, please look at the green line for renewables. Yeah. So this is a critical thing. Renewables are, of course, perfect environmentally. They get a top score of 100 points for being renewable. Can anyone tell me what the maybe difficulty is for bringing in a lot of renewable power? So say wind energy or PV? What might the problems or a problem be for the power grid? Okay, that's on the more sort of political side. It is in some countries it gets blocked from the utility. Yeah. True. Yeah, that is true. When we're looking at, so those are good points. What I would say, if I can add to that, is that when you have a certain amount of wind and solar power, right, you start to have issues with balancing your generation. The easiest example is at night, we're not producing very much solar power at all, almost none. Yeah, so when you ever see a chart of solar production, it starts, well, early morning, 7, and by around, 5 p.m., it's almost 0, and it's 0 across the evening. So I would love to have 100% solar PV generation, right? And it is possible, right? We don't want to say anything is impossible. It is possible at a certain cost. So as this is sort of a class, I want to open your mind a little bit. What could you do to use 100% solar PV? Battery, yes, very good. Right, so if you want to play tennis at night with a carbon fiber racket, then, and you have a 100% solar system, you need a battery supply to light the tennis court, right? Or for anything else you want to do in the evening. Absolutely possible. Only issue in this case is cost, but technologically speaking, no problem. All right, well, if you want to do that, you have to start to create really more advanced batteries. That's the first example we'll talk about, and we'll talk about it more later. That's the first example of where there are opportunities in the energy industry now that it's changing. We want to bring in, and look at the projection for renewable. That means we're going to bring in much more solar and much more wind power. And we're going to need a lot more battery support, or we'll say storage is a good way to think about it. Yeah. That's what we're looking at. And there are many, many technologies for storage. And the one that everyone understands, and the first is batteries, as the gentleman in the back said. But there are many, many other ideas. I'll give you one, which is called pumped air storage. This is quite interesting and efficient also. So during the daytime hours, when you have too much solar, run a compressor that pumps air into either a tank above ground or a storage facility underground, right? And then when you need it, you simply let the air back out through a turbine to make electricity. That's even more useful for, ironically, for wind power. So the wind is quite often blowing mostly at night in many places. And it's at the point of lowest consumption at night. Oh. I thought my speech was so amazing. Everyone's so excited. Oh, yeah. Sure. That's absolutely right. So there's a large field of research now in trying to determine exactly what the right percentage of each technology would be to keep everything balanced. So what that means is 100% wind and solar is difficult without additional technologies. So that can be batteries, right? It can also be, and much more logical and appropriate, at least for now, are gas-fired power plants. Gas-fired power plants are very flexible. If the wind slows down, you can very quickly push a gas power plant faster, right? They're just the turbines. You blow. Everyone cooks with gas at home. How fast does it take to start? 2 seconds, right? Now, what if you had to take coal to make dinner? Okay, 45 minutes later, it's really delicious, but not so fast. It's almost the same issue in a power plant. If you have a wind situation that slows down, coal power plants are much less flexible. Coal power plants are what's called base load energy. It's meant to run 24 hours a day. If you shut it down, it's going to take 24 hours to start it again. It's very expensive to do that because at the lower level of output, it's very inefficient. It likes to be run at the maximum capacity and stay there for as long as possible and shut down only for maintenance. Same with nuclear plants. Nuclear plants never want to shut down. They're wonderful for the base load that we use 24 hours a day. They're really not good for balancing with wind and solar, right? Because, well, actually, I'll explain what happens. This is an absolutely fascinating thing. In countries where they have both wind and nuclear, we see something called negative pricing. It's kind of advanced, but I think you guys are ready to handle the idea. Okay. If the wind goes up overnight, right? So remember the scenario. We have overnight period, wind and nuclear. And the consumption is very low. Everyone is sleeping. So the nuclear is running at the same speed, same capacity, all the time. If the wind goes higher overnight, which maybe there's a strong wind, can happen anytime. The power has nowhere to go. Absolutely nowhere to go. The amount of power from a normal power plant will produce only the amount we're using, but wind does whatever it wants. So we have to do what's called grounding. We basically send the wind power into the ground and send it away because we can't use it. It has to go somewhere. If we let it go into the system, it'll blow up every substation. So we have to send it into the ground. In larger systems, what we do is that wind power comes into the system, but they have to take the coal power plant and lower the power output. So they're balancing two systems together. But we said lowering the coal output makes it inefficient and it's expensive to bring it back up. So they have to pay money to the coal power plant owner to reduce the amount of energy that they're producing. So it's what's called a negative price. They're being paid to not produce. So that goes back to if you can think of, and this is happening now in Europe, if you can make a very efficient storage system, battery or pumped air or any other system, you can be paid to take the electricity and then paid again to give the electricity back the next day. Right? So, yes. John. The famous mathematician. The closest thing to what you're describing would be, I would say, linear optimization routines. Those are used quite frequently to determine in a huge portfolio which generators should run based on assumed consumption. We never know what the consumption will be, actually. We only know at every moment. I'll give you an idea. How can I do this? Now this is on. Not connected to the grid. Free will to turn on and off whatever we like. If the temperature is a little bit hotter than the power company expected, everyone will turn on their air conditioners. And so they're going to have to deliver more. So they have a prediction. They run linear optimization. What's called basically a dispatch model. Let me go back. I talked a little bit about all of the new interesting companies and jobs. I believe this gentleman. What is your name, sir? Yeah.
I mean, just in your suggestions on the overseas, water cooling and wind power on the same time, I can create true energies and once batteries. So I just never energy powerful. So power state is ever standing as all technologies. But I just want to 等一下，可以翻译好吗？对不起，因为只是在海水淡化跟能量上的话，已经有办法做到四种能源同时在一个电池里面，但是只是在台湾完全无法使用而已。所以刚刚那个提议只是在于是说，只限于台湾无法，但是国际都已经可以了。对，但是它没有将您刚刚所提的那个风能、海上风能两个在一起，因为你海水淡化会产生能量，那个能量可以储存下来，然后你风能本身也会产生能量，所以那可以二合一在一起。对。但是那是地方法令还是过不了，因为小弟在3年前就已经向那边七海那边申请过了，因为那边风真的很好，都很强，我也去那边申请，可是就没有办法成立电厂，都没办法。
Okay, let me try to connect back a couple of these ideas. So how does the mathematical model start to come into the system? And I pointed to this gentleman because I know he's doing some modeling work, and it's related to this idea. So if we know that there's a pool that has very high prices, how can we deliver power to that group more cheaply? Should we build a transmission line from another area? How much does that cost? What is the effect on the grid? Should we build a new power station right here in the center? Should we use new battery storage technology? What is the best way to reduce that price? If I can find the solution, I can get paid really good price for this power. It's very expensive. I'm going to sell at a really high price. That's one of the reasons for deregulation. It creates a price everyone can see, and it tells you where to focus your attention. And it makes the things more efficient. And that is done often with, again, linear optimization routines and dispatch models that try to predict what power plants should be run to match all of the consumption for the next day. Again, I was saying it's complicated because it doesn't always work the way we expect. So there needs to be backup power. The wind will blow more than we expect. Consumption is higher than we expect. The consumption occurs when we turn on the lights. The power company doesn't know until the actual moment. So we need many more technologies. The way around that is just to build so many power plants that we don't have to worry about it. But what's the problem with that? Is it cheap or expensive to build more power plants than we need? Really expensive. Really, really expensive. And also kind of dirty because then you're using one power plant only a few days per year. But that's the low-tech, kind of lazy solution. Just build lots of power plants and never worry about it. So, okay, let's move on a little bit. Okay, this I won't talk about very much. It's just to say that if we go back and we look at nuclear, the prediction is it won't rise quite as much as the other generation sources. But these are, again, baseload plants. If we shut them off, and each country decides what they want to do, again, we need something to replace it. Right? That can be coal. That can be, in some part, renewables plus other technologies. Or, I would say it's very interesting to think of energy efficiency and reducing consumption as part of the issue where nuclear plants are shut. Okay, so we have a long list of technologies. We'll start now. We'll end up taking a little bit of a break in the middle. Okay, so this I think I had yesterday. We talked about all of the new technologies coming in, and the past system is pretty much what some countries are still using now. Power generators, mostly coal, natural gas, nuclear power, some hydroelectric as well in some countries. Very simple, goes to high voltage transmission, to substation, transformer, and then to your home, commercial, industrial customer. Very simple. Very, very simple. This is important. This is the system operator. This is the utility company that is watching what is going on. And for the most part, they don't know what's going on, actually. Remember I said I turned this off? They don't know. You can turn off the lights? They don't know. You can turn on something? They really don't know. If you lose power in your apartment or your home, they don't know. A whole neighborhood, they don't know. It's amazing what little information they have. The only idea they get, if there's a large area that loses electricity, then the power generator itself will start to behave in a strange way. We'll try to slow down because of the consumption. When we use electricity, it pulls electricity from the generator. We are the main pressure on the system. We're the ones that are changing lights on and off. The power generator doesn't know this until the frequency, the wave of the electricity changes. If we turn everything off, if a neighborhood gets blacked out, they'll say, something strange is happening. But they don't know where. And that's because the only technology they have in the past is a telephone. They know when you call them, sorry, my electricity is out, I'm missing the baseball game. It's really bad. So they say, and then the neighbor calls, and then they put little pins in the map. Then they know what the problem is. Doesn't sound very good, right? Maybe you need a better way. So what's the better way? The better way is the first thing is to digitize make more interesting computer systems here. So at least now you can get better information about what is happening in the whole power grid. Also, they can now more easily communicate with the neighboring area, because the whole grid in many cases is connected together. If you have a problem in one area, it might cause a big problem in your area. So it's very important to be able to communicate through different regions. And so we've digitized and created really interesting software that has helped with all of this communication. Still, today, it's not perfect, right? Because one of the things we need are meters and sensors all around the grid. And that's one of the things that's being worked on now. It's an example of a technology that the energy community really needs. That's at two different levels, and we're going to talk about this as well today. At one level is on the grid, on the main grid. They're putting sensors at the substations and also on the high voltage transmission, so they know what the situation is if there's any blockage or outage at any point. Then also there's big discussion, I'm sure you've heard of smart meters. Smart meters is the same idea, but at the commercial and residential level. Most large industrial companies and very large commercial customers already have these smart meters. You'll also see now one of the other changes, wind power has started to come in, and solar here, and you'll see solar here as well at the customer level. But really not a huge change, right? It's an improvement, more efficient. But where we're going, and this is, for some places, this is now the reality, this future situation. So energy storage, I think we heard about that before. A lot of this energy storage is because of all of this wind and solar power that we mentioned. If you produce too much, only two choices. Put it in the ground or put it into an energy storage system. So one of you can have a wonderful job calculating which is better. Is the battery so expensive? We shouldn't do it. Really interesting thing, in Germany, the public is a bit upset. They don't want you putting wind power into the ground. But the grid operator said, well, but it's cheaper. If we have to build the batteries, actually, it's really expensive. So, but I think you guys will definitely understand the economic question. Lots of jobs now, lots of interesting technologies to start to calculate which one will be cheaper. The fascinating thing is you can't just calculate it one time. You calculate it once, and the next month, maybe a different answer. As the technology changes, cost of the battery goes down, everything will change. So you have storage here on the wholesale side, and then you have storage as well as wind and solar at the commercial and residential side. And basically same technologies, but they integrate into the system in a slightly different way. And one of the things we'll talk about as well is the microgrid. People are talking about cutting this and just trying to be self-sufficient in a much smaller community. Japan is one of the places talking about this, and the US as well. You have this energy service provider here, which is the middle company between the power generator and the customer. So that can be a company offering just green power. Very often this is the case. And then the last part, which I really love a lot, is the discussion of electric vehicles. We'll talk more about that later, but an electric vehicle includes at least two technologies we've already talked about. So electric vehicle first, of course, is consuming a large amount of electricity, which makes it a very large part of the power system, but also it contains a very large battery, which anyone who owns an electric vehicle has sitting there doing nothing most of the time. And many, many people are talking about how to use that battery for support of the system. Okay, so we have, I think, 10 different technologies. So before I start talking about all of this, let's take just a short break. Please get some coffee, and then you get 20 minutes. See you then. So we'll say at 10:45. Please come back. Okay, welcome back, everyone. I don't think we lost anyone. That's amazing. Sometimes half the room goes home. Thank you for staying. Okay, so let's continue. We're going to start talking about different specific technologies that are related to everything we talked about so far. Okay. We're going to start with an example of residential customer technologies. Okay. There's an important distinction. I brought this up again because this line from here to the left is the wholesale market, large power generators, large transmission lines, large substations. After this line is the homeowner, commercial, this is retail. It's called retail business. We generally do not make electricity here. We only buy electricity and use it as we like. Okay? So an important distinction. When I talk about retail, means this side. Okay, so the first technology example we're going to look at is a retail technology. So this is something I talked about yesterday. I like this example just because it gives us so many things to talk about. So it's on one hand just a thermostat. In Taiwan, you use when I was young, we had a thermostat on the wall. And it's, I guess, mercury based. Just turn a little dial. So what people are using, same thing here? Okay. Yeah, it works okay. Just turn. Not bad. But, well, maybe we can make something a little bit better. What can we do to make that old thermostat more useful? Right. Well, in the past, there was really no way to feed any information to the thermostat, right? The only thing that people could consider in the past was a remote control for the air conditioner. Okay, it's a little technology, makes good for being lazy, or good for when the air conditioner is too high. Okay, good to have remote control. This is a completely different concept. This is a company called Nest. It only came about, I would say, 2 years ago. And maybe in the last year it's maybe picking up. These are completely sold out. I can't buy one. Maybe the waiting list is some months to buy this. So what is it? Again, it's just a simple thermostat with a digital readout. But the first thing you can see is that, well, now I've made it web enabled. So I can control my thermostat from home or from my office or wherever I am. So let's say I'm coming home and I want to lower the air conditioning, right? Make the temperature more comfortable. Okay, that means all through the daytime, when I wasn't working, it was lower, push the button, and now I've saved a lot of energy. But it also has a lot of interesting technology that is predictive and starting to use artificial intelligence. So it has a function where it tries to remember where you are setting things during the week. So it tries to remember, oh, you're leaving for work at 8 a.m. We're going to start to turn off the air conditioner around that time on the weekdays. And it's going to start to think, oh, you probably come home 7 p.m. We're going to start to change the temperature based on your habits. It will also keep a history, energy history. So it's starting to show you when you're using more energy or less energy. Yes? It also has other small technologies where it will try to optimize your air conditioning system. So it turns it off fairly frequently and just keeps the fan running, which will save you money. The other thing it has as a feature is you can set the amount of money you want to spend as the temperature setting. So I want to be cool up to $100 in the month. Well, maybe it won't be the perfect temperature for me, but I know I will not spend more than $100 for that month on air conditioning. So how did this technology come about? Why do we have this now? Well, I think some people here can help even me to understand. I'm not a communications expert, but of course Wi-Fi technology very useful for these sorts of things, right? In the household, the customer controls everything in the household. You can't complain about Taipower or any other utility in the home. You, as the consumer, you can do whatever you want. No one can say, don't do that. Well, mostly. I'm sure there's something. But mostly, you can install anything you like. So a little bit of artificial intelligence and net enabled with lots of apps will help you to control all of this. So remember when I said residential on the line this way? This is one really interesting example of this kind of technology. Now, there are so many different things. We'll talk about a little bit of them later as well, but not just for your thermostat. Now you can start to look at everything we call in the electric industry, we call load. But it means any device that uses energy is load. Start to look at anything you can think of and say, oh, how can this save energy for the end user? And now you have something maybe you can sell, or you can market, or you can consult to a manufacturer, or you can start to think of ways to make everything greener, right? So environmentally friendly. And if it's using less electricity, it's also saving money that you can spend on nice things. It also actually helps the power company, because if you lower your consumption, it makes it easier for them to balance everything. Well, they're not going to say thank you, but anyway, it does help the whole system. Creates less pressure. Remember those very hot days where the air conditioner is really high? Everyone is using air conditioning. In many places around the world, the utility will tell everyone, please lower your air conditioner because it's a really hot day and we're having a problem. Does that happen here sometimes? In New York, we have that sometimes. They say, oh, everyone is using too much. Please reduce consumption. In the US, we have systems now where they will pay you to reduce consumption. We'll talk more about that too. But in any event, I turn on my dishwasher late at night just because I'm nice to the utility company. It makes me feel good. I don't get anything from it. Okay. So one example. Any questions about this? Please.
Should we develop a new function, like an app function? Maybe we can write a new Android function and put into the mobile and link with this system. Could it possible?
You mean like this?
Yeah.
Yeah, absolutely. That's so I think. And your phone. Oh, absolutely. I think this is exactly this situation. So I'm only smart enough to think about the thermostat, but everyone who's younger than me, and that's most of the world, is also thinking about apps for Android and Apple as well. So one of the things I said yesterday was that hardware is important, but software is just as important. So the question is, if they sold only the thermostat, would this be as popular? Maybe not. Maybe that's also really cool, right? And it's really fun for people to have control of the system. That's I guess we need is anyone a marketing person? Marketing specialist? Oh, we have two. Perfect. So you guys are the ones to help with that idea. I'm the energy guy, and I know I have fun playing with these things, but you're the guys who can think of, all right, well, what really is the way to get people to not only save energy and save cost, but also enjoy the process. One of the examples I talked about a little bit yesterday is the app developer. They've started to show the consumer, well, here is what you used. Here is what your neighbor used. Not the name, but your neighborhood. And they create a kind of competition. Who can save the most electricity? They do this also with Prius hybrid cars. They load the data onto the internet and they have a competition to see who can get the best efficiency. So maybe the marketing people can help with some of these ideas in terms of residential usage. It's really important because, well, if I see something that's energy efficient, I'm really happy, but I'm very unusual and rare. Most people don't care so much, about that. So actually, I think I'm going to stay over here. This side of the room has not gotten as much attention, so I'll pay more attention to you guys. Okay. Any other questions on this technology? Even though I'm over here, your side, don't think I'm ignoring you. You can still ask questions. It's okay. Okay. Please. I think your microphone is not on. That's a great question. Marketing people, general business consultants, I can imagine maybe it's like the early stage of the internet where you have 20 different web browsers. I can easily imagine what you're saying. And probably most of those apps won't be very good because it's a washing machine maker who's trying to make an app, and it won't look very nice, I guess. So there probably will be a company at some point in the future that will integrate all of those smaller apps into one function. It's a little bit like, you're reminding me of the television remote control. And at some point I had 5 remote controls. And then finally they got integrated into your phone or into a special TV remote that integrates everything. I don't know how all that plays out, but your point is very good. And that should create opportunities for people too. Mm-hmm. If they cooperate, yeah. Sure. That's if they start with some open source. A lot of this is being worked on, actually. I think we'll mention think we'll mention this a little bit later, but open source, if we can get more of this, it would be a wonderful thing. If everyone starts to create their own apps and nothing is consolidated, probably not the best thing for the consumer. I don't want to start to learn 100 different applications. Okay, retail appliances. This is an area also with great promise. For the most part, nothing exists yet. And the main reason is no one really knows what the residential consumer wants to do with a smart appliance. And how do you make a dishwasher smart? What will it do? The Whirlpool company has a lot of consultants and a lot of people thinking about this situation. I know that Samsung has a range of their own appliances. Yeah, this Samsung Smart series. It hasn't really caught on the same way that Nest thermostat has caught on. But someone will come up with the right way to make a smart appliance. I'm not expert enough, or my specialization is not white goods or appliances. My view of appliances is not what the appliance does, but what the appliance costs in terms of energy consumption. I always think of energy. I can look at anything and just see the energy. I look at a book. Oh, that probably took 1 kilowatt to produce. I can look at a water heater and say, that's a $430 per year machine. Right? So what should the water heater do? How can you communicate with it? I don't really know. Maybe you want to have a remote control of the water heater, maybe. But I do know that if that goes from $430 to $300, you'll be very happy. You'll be very, very happy. And then consider water heater, clothes dryer, dishwasher. It's quite expensive. And yesterday I was having lots of fun talking about toasters. Could you imagine? Even it's number 4 on this list from the U.S. Department of Energy, just the toaster. And I realized, oh God, the toaster. My toast is really expensive. How much am I paying for one slice of toast? Crazy. But how difficult would it be to create appliances that consume less energy? And just as importantly, a big part of this is the marketing, and that's why I asked these two gentlemen. We had a wonderful presentation from our Korean friend, Mr. Moon, yesterday. He was talking about the marketing side of green energy. For the retail space, I would have to say that's, again, not my specialization, but very important. We can create appliances that are smart or more energy efficient. Really difficult to show the consumer exactly how it's going to benefit them, and what we really should be doing. But my job is to show you the opportunity, what to think about. Oh, someone's calling to buy a toaster. All right, we're sold out. Sorry, hold on a minute. It's his wife. He has to take that. Okay. So if you look up at the top, ceiling fan, television, at this end, you have a price signal. Right? Remember the slide we looked at the beginning? The man who's living on the mountain is paying very high electricity cost? That's a price signal. Try to help that person reduce electric consumption. You'll make a lot of money, very environmentally friendly, good for supply security. This is the same price signal. It's telling you where to work, where is the biggest need in the home. The PC is one of the areas, it doesn't use a huge amount compared to everything else, but it's something that's taken a huge amount of people's attention. And there are a lot of systems, especially in commercial buildings, that are there to control all of the PCs in the office. So when the people leave at night and they don't turn anything off, the central controller can hit one switch and then turn everything off, or at least hibernate the entire system. Now imagine 40 floors of PCs that are running all night. So just maybe a $5,000 software system can be repaid maybe in 6 months or 1 year, I guess. Also, so good for the software company, good for the customer, good for the environment, and good for security of supply. Right? That's a little bit less coal or natural gas that we imported. We mentioned standards. That's right. So the EPRI and CEA have this new standard for communications. This is, I think, literally just earlier this month. So sorry, I don't know the details yet, but it's I think for the question before, this is trying to start to address that problem of how to have a Samsung dishwasher, right, and another company's washer dryer and microwave and other appliances, and have some standard code so that you can control everything relatively easily. I mentioned the Samsung only because they seem to be one of the few companies that is already trying to push and market smart appliances. Others are thinking about it, and I'm sure there are many others, but if you want to take a look at what's happening, that would be one area. Yeah, also a coffee maker, $86 a year? Oh my God, really expensive. And I'm sure, I didn't check what basic cost of electricity this is using, but I'm pretty sure it's much lower than my actual electricity cost. This is probably average for the US, which is, I think, around, let's say 8 or 9 cents, US cents. I pay 20 cents. That means twice as much money. Wow. Okay. Any questions up to here? We're good? Okay. Okay, time of use pricing. This is something that only exists in certain regions. And I have to say it's something that I think should be much more widespread. This one is something you have to actually rely on the government and the power utility to install. But there's a great opportunity because very few governments have put this in yet. I think the chart is the easiest way to understand the idea. Remember, go back to our man on the mountain idea? Well, this is a price signal to say to that guy, right? So between 7 to 11 a.m. and from 5 to 7 p.m. in this region, it's going to be very expensive for you to run your air conditioner, so please reduce it. So we talked before, the utility always needs the customer to cooperate a little bit, especially in really hot days. So in most of the world, and in New York as well, we have these electric warning days. So they, on an announcement on TV, please reduce your consumption today. But why should I do that? I'm really hot, and I just played tennis, and oh, it's terrible. So they're basically trying to hope that the consumer will just cooperate. But what happens if they don't cooperate? What is the result? What's the possible result? Blackout. Exactly. Now, this is another fascinating thing. If there are any psychology specialists in here, each country has a certain level of cooperation with these announcements. The US is so-so. Japan, everybody listens. 100%. It's amazing. I think there's one person in the whole country that didn't do it, and he's deaf and blind, so he doesn't hear anything. Really amazing. But in general, even in Japan, after 2 years of this public announcement, people start getting tired of eventually they want the air conditioner and television and everything again. So even there, the level of compliance, level of cooperation is going down. So there are two ways, financial, economic ways to manage this. One way is what we call the stick. If you use electricity at the wrong time, we will hit you with a high price. So that's why it's called time of use pricing, right? Now, it works very well. Everyone's like, oh, I'll be afraid. In places that have this, people switch to putting on the dishwasher overnight. The price is lower. They boil water overnight and then store for the next day in the thermos. They change their behavior, right? But again, this is the stick way. I'll punish you if you don't do what we like. The other way is what we call the carrot way. It's the reward, which again is to say, if you turn off the electricity, we will pay you when we need. And both ways, I would say, are okay. They both get generally the same result. Now, how can the utility pay you to turn off the electricity? Basically, what has occurred is that when on those few days the consumption is really high, the power company has 1 or 2 backup power stations, and they almost never use them, just a few times per year, which is pretty inefficient. But they have to build them, otherwise we might have a blackout because people are consuming whatever they want. So they calculated, the utility and the government calculated, if we can reduce consumption by a certain amount, just a few days a year, there's 1 or 2 power plants we don't need to construct. Those power plants are really expensive to build, and they're really expensive to operate because they're not very efficient. So these are the power plants that are the most expensive and the most polluting. Those are really bad for the environment and for costs. So the idea is, well, if it costs, let's say, $400 million to construct the power plant. Sorry, it's a big number. I have to calculate. It costs 400 to build. If the power company gives the customer back 200, okay, utility has saved 200, and the customer has gotten the carrot for helping by reducing the consumption just a few days a year. Okay? So again, 2 systems. On the industrial part of the market and the commercial part of the market, both systems are already in place in the US for large customers. Large customers always pay more money in the daytime. So big factories. And they always pay less money at night. And so there's always someone at the factory calculating when should we do our production. Right? Factories are very sophisticated in this way. The commercial side, it's starting to come in more and more for large office buildings. In the US, we have this program now in maybe 2/3 or 3/4 of the country has this for commercial buildings. So that means if the commercial building is asked to reduce consumption, they get paid. So the commercial building manager, I'm sure there's someone in here somewhere, needs to know, oh, how do I control the escalator, turn off the air conditioner, some of the lights, maybe an elevator, escalator, whatever they want to do, they can do to turn off the power. So they get paid. Remember the fee, 400 for the power plant? Well, they get paid 200 just to cooperate. Even if the power company says, oh, it's okay this year, you don't have to turn off the power, they still get paid because they didn't pay for the power plant. What a great idea. Do nothing and get paid. And it's actually a large amount of money. You can get, a medium building can get $25,000 a year. A large building can get $100,000 a year. The cost of the power plant is huge, really huge. And so if we take that money and spread it through all of the commercial buildings, they can really make very good money. Then also, if they're asked to reduce the power, they get paid also separately for the amount of power that they reduced. So this is all in one big system called DR. It's demand side reduction or demand response programs. As I mentioned, unfortunately, that's something that would be in conjunction with the utility. So that's not as easy to do. But for the residential customer as well, anywhere that you have this type of time of use pricing, you can think of an app. App was mentioned. That's a really good thing to put on an app to show the customer, oh, it's good to turn on your dishwasher now at this time. Eventually, there'll be more integration, so the app will just turn your air conditioner on and off when the price is high or low to save you money. Now again, not all of this has been figured out. Maybe someone in the room can start to work on this and figure out how to combine the app and the pricing and the appliance. No one has figured this out yet. We know someone will figure it out somewhere. I don't know who, I don't know where, but I see the need. And I see the benefit for the customer, new good business, environmental friendly, and also good for the whole system. Okay, so what did I write here? Time of use prices reflect the fact that the cost to provide electricity changes throughout the day. Got it? Just means prices are changing. When demand is low, they can use cheaper generators. But when prices and consumption goes up, those really expensive last two generators have to be used. That's really bad. Okay. Sorry, that's a little bit maybe not intuitive, but was that hopefully understandable, the concept? Yeah, I'm sorry I can't just put an example in front of you. It's sort of conceptual. But any questions on that topic? Please.
Time of use pricing in residential?
Sure, absolutely. I'll give you two examples. One is on the demand response side. So in New York State, there's a demand response program. Sorry? Not anymore. No, it's actually been in place now for a few years. You can look at a company called World Energy. That's one company that provides the service. Another one is called Enernoc. Third one is Comverge. These are three you can look at. So what they do is they work between the utility and the end commercial building consumer. In residential, this is still basically pilot for residential. One of the main reasons is you need communications, and that means smart meter. And most commercial buildings have no problem paying for a smart meter. Yeah, exactly. So this can easily be done then in Taiwan. Everyone has a smart meter for commercial. But residential takes more effort. Everything in energy goes from industrial to commercial to residential. Industrial are huge users, very few. Commercial in the middle, custom residential, always is last. Always, always. Yes. That's true. It's country by country. It's true, and so I think what you're saying is that it is important eventually for these programs to come in. The way that things work, not right or wrong, the utility says we want to put in a program, and there are 1,000 industrial users, 10,000 commercial users, and 100,000 residential customers. So the utility doesn't have enough people to talk to everyone. Eventually they do, but so in terms of the demand response programs, they are at the industrial and now more and more at the commercial level. Eventually, they'll come into the residential level. I'll give you a much clearer example. I have a potential large customer for my business. They have many thousands of apartments in the New York area. They've asked me maybe to help them to start to do this business for their apartment buildings. Mostly they'll start with the things I pointed to before. So water heater, clothes dryer, dishwasher, toaster oven, this area, right? So what they want to do is aggregate all of the apartments so that it looks like a commercial property. If they can put enough together, then it's big enough, and then they can join the program and get quite a lot of money. They would have to spend a reasonable amount for control devices. So that's what we'll research. Do we have control devices that are cheap enough to join in this type of program? So we're right on the edge. It's just starting in the residential side. There are places, if you do some research, you'll see it's very spotty in different regions. The time of use pricing exists. So California is one that uses this time of use pricing for residential. This is much more common, this system. New York doesn't have it. California does. They have 2 times. How do they know peak and off-peak? How do they know when you are using electricity without an advanced meter? Yeah. So you have a smart meter. Oh, just two separate analog meters. Very low tech. So if they want to change the time of peak and off-peak, really hard. Really hard, yeah, okay. Well, okay, so that's better than nothing. Better than nothing. So the concept for you then is very natural, right? So do all of the, how much in Taiwan is the price difference? Peak to off-peak. Well, what is the spread or the difference? Yeah, okay, that points to it's not enough to care. Yeah, it's probably not enough to really care. So do people in Taiwan pay a lot of attention to use electricity at night instead of the daytime? Yeah, okay, so yeah. Well, so it's a wonderful thing then. You basically have the concept already. Imagine the concept becoming 3-tier, 4-tier, 5-tier, or can even be hourly. To be honest, so that the consumer isn't too burdened, it works better to have 2 or 3-tier and then maybe seasons. So summer is more expensive than winter. Noontime is more expensive than daytime. You don't want to make it too complicated. Industrial customers, it's hourly. Commercial also sometimes. But now, so go back to, I'm explaining the energy system. It's what I know best. You can start to really use your imagination. How can the consumer have interesting tools to follow this trend. And yesterday I mentioned one example. We don't have so many yet, but there's one company in California that made an electric ball. It connects, I think, through Wi-Fi to the California system operator, the basically organization that publishes the pricing. And the pricing changes quite often in California. So there's a ball, and it changes colors based on the price of electricity. So it's supposed to send you a signal, and you leave it in your living room. And so you don't have to look at your app all the time. That's the way, and it turns, I think, green to red when prices are very high as well. It's one concept. I think it's kind of cute. I don't know if I would use it personally, but it's just one idea to give you. Okay, digital meters is something we just talked about, basically. It's the pathways for the utility to start to communicate with the end consumers. But here's the thing. It's not required for just residential applications. If you remember, we talked about the thermostat at the beginning. That doesn't need a smart meter at all. And this is an important part of the discussion. Smart meters are what the utility is installing worldwide to communicate between the utility, the wholesale provider, and the retail provider. Right? This provides mostly information for the utility. They can also potentially send you a price signal through that meter, but it doesn't have to be through that meter. It can be through the internet. So the residential side can be very happy, right, with using internet technology, and there are new standards. Zigbee radio is one for sending communications, and there's radio frequency as well. So it's important to keep in mind these meters are mostly if you want to work on the wholesale side of the business. So what does the smart meter do for the utility? So first and foremost, because the utility is getting data constantly, it means they can send you a bill at the end of the month without having to send the trucks and the people to each home to read the meters. I assume because you have analog meters, you have someone visiting you once a month to read these meters. Well, that's inefficient, and you have trucks running around the city. Much more efficient just to use the internet for this. But the other important part for the utility is, remember we said at the beginning that they have a telephone only? Well, this starts to solve the problem of the telephone. Now they know, oh, there's no signal coming from your home. Oh, maybe you don't have electricity. It's a problem. And if they see that in one, now they can make a map. And they can put a map up of what area. Maybe there's a storm, lightning, some high wind. Now they know, this area has a problem. Let's start to think about how to fix this before people start to call and complain. The other part of that is the utilities like this because it's kind of bad to say, because if you have a customer that isn't paying their bill, it's really easy for them to cut the service. Not good for us maybe, but the utilities like that also. But they won't tell you. Yeah, please.
Last year, the hurricane hit New York City area.
Right.
And the power problem, it took more than 1 month or more than once, for the company to fix. I don't know what's the problem, what's the major problem, it takes so long, many people complain.
So I've done studies on blackouts in the past, and the reason for about 98% of blackouts is weather related, storms. So anywhere that you have above ground distribution lines, it's really easy for trees to fall on top of it or them to get knocked down. And the utilities, it takes a lot of time. The utility doesn't know where all of the lines have fallen. It's a big problem. So it's two parts. First, it's easy to knock down lines because there are so many. and especially in a big storm. But the second problem that I actually know someone trying to create a system to fix this problem is the utility doesn't know exactly where all of the lines fell down because they don't have communication with the customer through a smart meter, and they don't have any communication or meters on the poles, on the lines themselves. So if someone doesn't tell them there's a line down here, they don't know. So this is one of the reasons it took so long. It's a more reliable, more expensive. Much more expensive to put lines underground, much cheaper above ground. Okay, electric vehicles. This is one of my very favorite technologies. It lets me learn a lot about the transportation sector, which I never really studied in the past. But electric vehicles are massive consumers of electricity. It's basically taking all of the oil you would have put as diesel or gasoline into your car, and it uses it instead as nuclear, coal, natural gas, or renewable energy through the transmission system. Imagine 50% of all energy consumption is transportation. The other 50% is electric. So that's a huge amount of energy. And as electric vehicles slowly come into the system, it's a massive, massive new part of the grid. Right? The oil companies will eventually become power utilities. Might take many decades, many tens of years, but eventually this will occur. So, what does this system look like? It's a bit complicated, but we talked about the peak, the time of day in the middle of the day. I mentioned this is the really expensive time, highest demand. I remember I made a joke, the Japanese go to lunch all the same time, right here. Turn off the computers. So the issue is if you plug in your car too many at this time, it's really going to overload the system. So we talked about air conditioning and lowering your consumption, and the utilities really want to either make you pay more or give you money to manage your air conditioner. Well, what if it's electric vehicles? They really need to make a system to manage this. If too many electric vehicles come in at the wrong time, it's a huge burden on the power grid. That creates massive new opportunities. First, to manage the pricing for plugging in vehicles. And I have to say, no one has any solution for this yet at all. There aren't enough electric vehicles for the utility to worry too much right now. But they're really, really worried about 2, 3, 5 years from now. Really worried. How can we manage electric vehicles in the power system? The substations, there's not enough. The transformers can't handle this amount of power, and the transformers don't last as long when you have a lot of load like this. They get very hot and they can't cool down. But there's a nice solution. That goes back to the idea of storage. The car is sitting there doing nothing most of the day. Drive to work, right? Go to work and the car is sitting there. Right? Drive home and you're sleeping and the car is sitting there. You're only using it 1 hour per day. That means there's 23 hours of battery sitting there doing nothing, waiting for charging and then sending power back to give the grid more support. Okay, now that's really complicated, but really interesting. So electric vehicle part is the consumption, just charging. Then the other idea for storage is VTG, vehicle to grid, sending electricity back when it's needed. Now, remember the idea, oh, we have too much wind power. Well, what if you can connect the extra wind power and the utility, well, let's see, they can send the electricity into the ground, or they can pay you to put it in your car. Wow, it's actually not just free, you get paid to take the electricity. So to give you a real-life example, this is what's happening in places, so for example, Germany and Denmark and Texas, where they have a lot of wind power. Overnight, they don't have a use for it. Instead of telling the coal plant to come down, they want to keep the coal plant running at high efficiency. So instead, take that electricity and send it into your car. Really nice idea. We need a huge amount of infrastructure to do that. We need what? We need apps. We need a good pricing structure. We need to know that it's a car and not a toaster that's plugged in. It'll take a huge amount of infrastructure, a huge opportunity, but it will make the system potentially really, really efficient. It's a wonderful idea. I can't wait for this. There are some researchers doing work in this area. One in particular, I think University of, Maryland in the U.S. is specializing in this, and some people in California as well. The utilities, to be honest with you, don't really know how to handle this. They know they have a problem, but they're maybe looking for people to give them some idea, some solution. Also, it's an extra complication because it's a vehicle. Vehicle means car industry. And so now you have the consumer and the utility company, and now the auto industry trying to figure out how to cooperate. Wow, really complicated, but really interesting. Yes?
Yeah, my question is, what is the storage capacity or the BTG? Sometimes you overproduction of electricity can ruin and destroy storage facility.
Right. So the batteries are of all different sizes, but I would say you could expect some 15 to 30 kilowatt hours for a standard, or some of the larger ones are 60 or 90 kilowatt hours. So actually quite large. Quite large. More than, say, 10 houses. 10 houses worth of power for an hour.
I just want to know if I can deal with these questions. Who is right man, or how can be contained with them?
I'm sorry, please.
About the electronic problem,
Mm-hmm.
Who can be contained with them? Give them to answer.
I'm sorry, I'm not quite understand.
因为刚刚所提的那些问题的话，小弟如果办法解决的话，请问要找哪位做窗口记录联络？
Yes. Who do you go to? Oh, it's such a good question. So first come up with the solution. Then you have multiple choices, and it will depend on basically where you are in the world and who is interested. So I'll give you an example. In the US, there are 3 possibilities. So the first is, of course, the power utility. The power utility is trying to figure out what they want to do. The power utility doesn't want to own the car, but they really want to own the battery. So it's a kind of a business model issue. I'm discussing this with one utility in the US. They really want to own the battery. They love batteries. But they don't want to own the car. Right? So then second opportunity is the auto industry. The auto industry wants to own the car, maybe doesn't want to own the battery. The battery is kind of a headache for them. And then, so you have the power utility, you have the auto industry, and then the third would be a software company like Google. So I'm watching to see which type of company is going to take the lead in this area. Google has a lot of ideas, Google type companies, to manage and control all of these systems.
在3个里面的话，第2个的话，在美国密西西比州，它里面就已经有技术了，它已经有专利在。 就是刚刚所提的3个项目里面，第二项已经在密西西比州里面已经有专利了，州地方政府所有。就是在车用电池以及跟车辆有关的。
Well, there are so many companies making a car battery. So the technology, all of it exists. The electric vehicle is there. There are steps missing for the battery to be connected to the grid with two-way communication. One way is no problem. So it's the two-way part. The batteries are fairly standard and improving, but it's all of the control and communication and business model that's missing, and that's a huge area.
那对不起，第1项跟第3项的话，是否哪边可以去做联络？这样，就是在第1个电池跟第3个 software 的地方的话。
The battery solution is more of a, sort of the chemical, industry. The battery industry is really trying hard to make better batteries, and they're having progress, but it's relatively slow. Really little by little. And Josh, the second, batteries and communication side is completely open. So how should the car and the battery in the car communicate with the power utility? And this other part you can think about also is the app that the end consumer will have on their phone to see what's going on with the car. I think Tesla has maybe an app for their car. Yeah, you can see your car's battery condition, use your phone to, I don't know, start your car, drive your car, do lots of things. Okay, so let's move on. Okay, demand response, actually, we talked all about this before, so I'm going to skip through this slide. We talked about this when we talked about time of use pricing. This is an example, screen example of controlling the commercial building pricing. We can come back to this at the end again if you have more questions, but we already covered it. So I will move on to energy storage. So these are the batteries themselves, but this is at the wholesale level. So we talked about, again, it's possible to use batteries in electric vehicles to store the energy at the customer level, but we don't have that system yet. So utilities are looking at very, very large 1 to 10 megawatt batteries, huge storage devices. And most of these are in places where first there's a lot of wind energy and solar. And second is where there's a missing or lack of transmission. So if you think about the man on the mountain, during the daytime, it's very hard to get electricity to that person. So what the utilities will do is they'll put a big battery at that location. Overnight, when it's easy to get electricity to that location, they send it into the battery, and then during the daytime, they use the battery as a basically virtual power plant. So instead of building a power plant in that location, they'll put a battery there instead. So you can think of 3 equivalents. If there's an area that has high prices or lack of generation, you can put a power plant, or you can put a power plant outside and build more transmission lines into that region, or you can put a battery there. There's 3 different things to analyze. And again, the prices change all the time. Okay, building energy management.
Yeah, in the last slide, I say
yes.
Usually how long, every time you store electricity, it loses some electricity, So usually, any limitation for the time for storing the electricity?
The amount of time that it's stored in the battery is basically unlimited. You can store it and leave it there as long as you like, but usually it's most efficient when you're using this in a daily cycle. So off-peak, you're taking electricity, and then during the daytime, on-peak, you're giving it back. It's usually a daily cycle.
I agree. Yes, usually when you store, try to use it as soon as possible, because efficiency is extremely important,
Yeah, it depends on the pricing. If you buy at $10 overnight, if the next day, if the pricing doesn't go up very much, sometimes it happens in the winter, then no reason to give it back. Just leave it there. It's possible you buy it at 10 and daytime price is 9. It can happen.
Yeah, storage usually is not a serious problem. Transmission, electricity could be a problem. Now wind power, transmitting, usually lose a lot of electricity, so wind power is still under research, It's a transmission problem.
It's a transmission problem as well. We had mentioned, of course, you can build new transmission or you can put a battery in a location. But you can also use batteries as an economic arbitrage. You put a battery in a place, you buy it at cheap, and you sell it expensive. So you need to predict what will prices be over the next 5 years. Is that better for me compared to the cost of the battery? Okay, building energy management systems. These are, in a very simple way, these are apps for buildings. Much more complicated. So the app we showed at the beginning was for your thermostat. And we had the comment before that, well, we have lots of apps maybe for every appliance that you'll buy, possibly. Well, these days, almost every building now is installing or already has an app, basically computer based, that controls as much of the building as possible. Again, the lighting, elevators, all of the heating, ventilation, air conditioning systems, the valves, air handlers, as much as possible. This is a really good area. It's very efficient, especially connected to demand response programs. So if you have a demand response program, the utility says, please reduce your consumption, you can do it easily at the computer instead of running around switching off lights everywhere. Right? You can imagine, okay, this is now in the commercial space. We said eventually everything will become residential. Right? So those apps on your phone and this will start to merge together. If you want to do residential work, study the building energy management systems. You'll have some ideas for what to do for the residential side. Okay, we'll go through just for a minute. I'll mention this only for your own research. I want to leave some time for question and answer. So I've worked with Neto from Japan. US and Japan have done some cooperative projects to take lots of these technologies and install them in test projects to see how they all work together. So these are computer-based control systems, fuel cells, combined with energy-efficient buildings and electric vehicles and wind and solar. And what happens if you throw all of that together into the system? Do research. What is the cost? What is the benefit to the system? How much more environmentally friendly is it? And is it stable? These are basically smart grid projects, but now they're also called microgrid projects, and they include green buildings, both the generation and the end user. And there are, I want to say, probably more than 1,000 projects around the world that are testing all of these things. This is just one that I was involved with. Very easy to just type in smart grid project, and you'll have more examples. You can read these things forever. This is a laboratory. I actually just visited this group in Germany last week. They are not a test project, but they're a laboratory. So they're testing new equipment all the time. And I think they like their job. It's fun. Just to get lots of new toys, lots of new generation, lots of new equipment. So they have a room with washing machines and dishwashers and all sorts of things, and a little refrigerator. I teased them. I said, there's no beer in the refrigerator. So bad. And last example, this is a few of the test projects around the US. This is only a very small sample from one group of utilities that are doing tests. I highly recommend if you can start some test projects in Taiwan, if you're a university student or connected to the university or some of the government research groups. Doesn't have to be big or expensive, just a really small project, one solar panel, one small wind turbine, one end load device, and some controller. You can have your own tiny smart grid test project. This I won't go through. There's just one more large Pacific Northwest project. This is a huge one, $200 million project that has multiple technologies. Then very briefly, some things to think about. We mentioned things go from industrial, commercial, and residential. So the future will see a full integration of power systems for the home and the utility grid, and also then and now for transportation with electric vehicles going forward. It's inevitable. It will absolutely happen everywhere. Some countries faster, some countries more slowly, but it absolutely will happen. Electricity is much more efficient overall than using oil. So system controls will go from providing remote access to prediction and automation. So what we were saying was your television remote control is just remote access. But all of these tools will start to think for you about how you like to use your equipment. We mentioned the thermostat, right? So it starts to remember when you leave, when you come back, what you like as your temperature. So it's an artificial intelligence opportunity for all appliances. And so we mentioned this as well, smart meters. It's brought up all the time. People say a smart meter equals smart grid, and I disagree completely. Smart meter is just one small part of the smart grid. They're important, but as a residential owner, it's not so critical, more useful for the utility. Generation and load are of equal value. We talked about building a new power plant or reducing consumption. Reducing consumption might even have greater value to the society and the system. And last, I mentioned this yesterday, both software and hardware are equally important. Maybe we can say software is even more important going forward than the hardware. Everyone can make hardware. Not everyone knows how to think about the usage and can make something really nice for the end customer, and that's useful. Okay, I talked a lot. Please, question and answer. I think that side needs to help with question and answer. Maybe this side did a lot of work. Yes.
I think 2 years ago, the Japanese, nuclear power plant, the problem in Fukushima, it's not a problem of nuclear power plant. It's a problem of human error operation. That's a major problem. We cannot say, because of human error of pilot, and then we stop building airplane. That's not right. We should continue to build, power plant. I say, either you want to use it or not. That's another issue, in the future. But you definitely need, you need energy. Then right now, nuclear power plant is still the most, the most environmental friendly, compared with many other, solar energy, solar battery is notorious for environment and ecosystem.
I think I know where you're going with that, and I don't say I know the right answer for the mixture of generation sources, but what I really want to promote is to have a really deep conversation, logical conversation for each region or each country, to think about all the resources and the benefits and the dangers. Every generation source has a benefit and a danger, right? Coal is very cheap. but causes huge amounts of lung problems and environmental problems. Wind is incredibly friendly for the environment, but expensive and doesn't run all the time, right? Natural gas, somewhere in the middle. Each one has some problem and some benefit. And so I think it's really worth, in a not so excited way, in a very reasonable, rational way, to talk about each of these things. And the answer will be always some balance of multiple sources of generation, never one. So, hope that helps.
Chinese, Chinese saying is, once you have a great mountain, you don't really worry, not enough, wood for future heating usage. So, once you build power plant, either you want to operate it in the future, that's another issue, But once you have power plant, you got, a lot of potential, for energy, future usage,
Yeah, power plants are typically 20 to 40 or even 60-year investments. So that's, again, why I say it's really useful to have a good conversation about the future of your energy consumption, with people researching the area and, having good open discussion about what to do. Every country has a different need. So, okay, thank you. You only have one more chance, Eva, when I fly back to New York. You said, I should have asked. My office? It's the Woolworth building. One more? That's where I go every day. I always joke, my office is all the way down here. 5th floor. Really sad. Oh, but I have a nice view. This park, actually my office is right here, so I can see all the green. It's really nice. Oh, what's that? Oh, yeah, that's pretty lucky, actually. I actually am. I'm lucky all the time.
I have a question, maybe not directly related to this. While I was a chance to study with Washington School, but that company, they all emphasize kind of good innovation, creative company like Enron. That's the reason why I raised that question. The business you are talking related is energy management or originate really came from Enron.
Enron was part of this idea. I have to say the management of Enron was not very good. But the staff, the ones I met, were really thinking very hard about how to make some new business. Most of their business was on just the financial side of the business. Not so much innovating in the way we're talking about it, but to say, well, we can create a new market for something. But I would say, yeah, generally it's the right mindset. Yesterday I made an example. I kept talking about the toaster. So the toaster is $50 and I'm paying $100 for electricity. So am I buying a toaster or am I buying electricity? Over 10 years, it's $50 for the toaster and $1,000 for the electricity. So that should lead to a new business opportunity. Whether you want to reduce power for the toaster or in some way be on the electricity side. So I don't want to make a toaster. I want to manage, and I want the $1,000. I want part of that. If I get only $80, I still made twice as much money as the toaster company. Right? So that's kind of the Enron maybe mindset that the way they would think about it. Where's the real opportunity? Oh, where is the local bar for drinking? I can't answer unless I have a beer or two. Idle assets. sorry, I'm not too familiar with this process. Oh, okay. Sure. This, what you're saying, just the general idea of manufacturing efficiency, of course, is something that is being done all the time. This example, or the examples we've looked at, are more advanced levels of efficiency in a very specific area of energy. There's so many people that are experts in equipment efficiency and water efficiency. And there are many interesting, exciting things happening in many, many different areas. This is just one part of new types of efficiency that can be created, very specific to electricity. That, again, I always mention helps three ways. So first, the cost for the consumer, and then the environment generally benefits when we reduce consumption. And then number three, it generally helps all of society. When we are reducing consumption, it makes the system more efficient and less likely for blackout. I think we have time for just one more. Who has a really big question for me? Okay, you get the icing on the cake.
I have a suggestion about the last, waste energy.
Please speak up so I can hear you.
Yeah, I mean the water heater and the clothes dryer can do this way to separate every detail. Total charge is the 430. Okay, can separate every detail. Maybe the tube transportation. The temperature and the tank, every detail, and how about the function? Okay, then I think I have a good chance to change something inside. Then maybe you can reduce the 50%. Maybe.
Please.
I think, yeah. I can give you the answer if you can give me all the detail very quickly within 10 minutes.
That's a very positive, optimistic view. I hope you are correct. What I'm trying to bring to you is the knowledge of how much that efficiency is worth. I think that's a big incentive for people to work hard to take that money. That money equals environmental benefit and equals supply security. So the cost issue helps show people where their efforts are needed. And if you can do that, everybody, I think, would be very happy and buy you the beer. Great.
I have experience in Seoul, and the winter time, very cold, and their tube a problem. For the firemen, they very headache about it. When the winter time have the fire accident, then fire accident then cannot transport the water, the ice, and the tube is broken. That is example. So all the residential hotel system, the headache about the waste, the energy. When you add the temperature but lose on the way, the transportation, lose the temperature very quickly. So if we can stop the temperature transportation, but no, the transit to other space, then I think it's very easy to control the temperature inside the tube and the tank.
So what you're talking about is very useful. It's a similar idea to what we're talking about. So in this example, I wanted to bring standardized examples where the situation is the same everywhere. So everyone will use a water heater, water tank. And if someone can innovate and make it more efficient, okay, everyone can put it in their home. What you're talking about is industrial level energy efficiency and what we call waste heat recovery. Those are also hugely beneficial, very important, what you're talking about. However, it's not standard. It's not the same everywhere. It's different in every situation. Every factory, every city, every fire department has a slightly different problem. It's a really good, I think your speaker, Mr. Ghosh, I think is in the afternoon. He's a waste to energy expert. That's a good example. It's different everywhere. The waste is different everywhere. Regulations are different everywhere. What he's doing is very important, but it's not easy to just show the water heater. He has to research every project separately. So both sides are interesting. For our discussion, we just dealt with the more simple way today, but I certainly encourage you, if you have the interest, waste heat recovery is also very good. And so, thank you very much for your time and attention today. If you have any questions, please don't hesitate to ask.